All right, let's start off on number 2 here. So for this one, we're describing the transformations. So anytime we have a number adding or subtracting out back, that's always an up or down shift. Really important that it is adding or subtracting. And it's logical here for this shift. So if it's subtracting, it's going to be down. And if it's adding, it's going to be up. So this is going to be a shift down 8. The other transformation we see is this 1/2 multiplying in front. Now, multipliers are always a stretch or a shrink. And how you know is just if it's a number that's less than 1, that's going to be a shrink. Greater than 1 is going to be a stretch. So this is just a little fraction here. So that's going to be a vertical shrink, since it's a fraction. All right, next up here we got number 4. So this one we see we have some adding or subtracting inside of the parentheses. So whenever it's adding or subtracting inside, that's a left or right shift. This is kind of counterintuitive. So it's the opposite way you would think. So you would think that +5 would be to the right, but it's actually a shift to the left by 5. And so that's that. Next up here, we kind of have two things out front, and I'm going to deal with them separately, which is probably the best idea. So first of all, we have a negative there. So the negative is always a reflection. When it's out front like this, that's going to be an x-axis reflection. So it's just going to be upside down. And then next thing I'm going to deal with is the 8. And so the 8 right there is going to be a vertical stretch or shrink, since that's a multiplier. Now, since it's multiplied by a number greater than 1, and once again, I'm thinking that as an 8, not a -8, it's going to be a vertical stretch. The reason I don't think of that as a -8 is because the negative was taken care of with the x-axis reflection. So the 8 is just by itself as a vertical stretch. All right, next up we have number 6 here. So on this one, we have some adding going on inside and outside, so we'll see both. So the inside is a shift left or right, and it's the opposite way you would think. So you would think that would be right 6, but it's actually left 6. And then the outside one is another shift, and that's up or down, but it's the same way you would think. So you'd think that negative would be down, and it actually is. So the x lies here, but the y tells the truth. However, we do have one more thing here, which is this negative out front, and so that is, again, going to be a reflection across the x-axis anytime you have a negative out front. Let's write that a little neater. All right, next up here, number 8, we're going to find the vertex, axis of symmetry, and y-intercept. So let's start off with the vertex. And so for the vertex, we always start off with x equals -b over 2a. We do have a -b here, so b is -4, so we're going to put +4 over 2 times -2. And so that's 4 over -4, and that's -1. And so that's our x value. So now we got to find our y value. So we're going to plug that -1 back in for every x back into this function. So we got -1 squared minus 4 times -1 minus 4. All right, so we have to do PEMDAS. We have to do our exponent first. So I'm going to leave that -2 there. I got to square -1, which is +1. So just do your exponent, and then we need to do our multiplications. That becomes -2. This actually becomes +4 minus 4. And now we need to do our addition. So we have -2 plus 4 is 2. 2 minus 4 is -2. So our vertex here is going to be -1 comma -2. And so that's going to be right there. And then we need to find our y-intercept. Actually, before we do, let's go ahead and do our axis of symmetry. That's always the x equals the x value of the vertex. So that's a vertical line that just goes right through the vertex. It's not really part of the graph, it's just to help. And then the y-intercept is always 0 comma c. And so that would be, in this case, 0 comma -4, since we have that -4 out back. And so that's there. Now, remember that there's always a matching point on the other side of the axis of symmetry. So I'm going to put that one there. And then we can just draw our parabola. All right, next up here, they want us to state whether this function is a max or a min value. So first of all, I make that decision based on A. So this one is going to have a min value because it's kind of an opening up parabola. You can see the vertex is the minimum. It's the lowest point. Now, to actually find that value is the y value of the vertex. So I'm going to do x equals -b over 2a. So negative 16 over 4 is negative 4. So that's the x value of the vertex, but I really need the y value. So I'm going to go ahead and plug this in. 2 times negative 4 squared plus 16 times negative 4 plus 1. I need to do my PEMDAS again, so I need to do exponents. So this will be negative 4 squared is a positive 16. All right, I'm going to need some more space for this, so give me a sec. All right, so now we need to do our multiplication. So let's see, 16 times 2 is just 32. 16 times 4, I don't know that one off the top of my head. So I'll go over here and do that. So that's 64, but since there was a negative there, it's minus 64. And then lastly, we'll do our addition subtraction. So 32 minus 64 is negative 32, plus 1 is negative 31. So that is our answer for part B, the y value of the vertex, in this case, negative 31. All right, lastly, we need the domain and range. So I'll do that for part C. The domain on all quadratics is all real numbers. And then the range here, if you kind of visualize this graph way back here, you can see that the lowest point is negative 31. And then all the y values are greater than that. So since it's a min value, all of my parabola is greater than or equal to negative 31. All right, next up here, number 12. So this one again, a max or a min. This one's going to be a max because we can see A is negative. So if A is negative, we know it's going to be an upside down parabola, so the vertex is the highest point. And then for part B, we're going to do negative b over 2a, which in this case, b is 3. So I'm going to put negative 3 over 2 times negative 1. And so then we get negative 3 over negative 2, which is actually just 3 over 2. Now for my y value, I do need to plug that in for all the x's. And then we will do our PEMDAS. So I'm going to do the exponents first. So squaring the fraction is going to turn it into 9 over 4. For squaring a fraction, you just square the top and square the bottom. And now I'm going to do my multiplication. So this will become negative 9 over 4. This one, we have to multiply top times top up top. So that's positive 9. And then bottom times bottom on bottom will be 2. And then this one I'm going to call 2 over 1. So now I need to add these together with common denominator. So I'm multiplying this one by 2 and multiplying this one by 4 so I can get that common denominator of 4. So I got negative 9 over 4 plus 18 over 4 plus 8 over 4. And now I need to add these all together by adding the numerator but keeping that common denominator the same as 4. Negative 9 plus 18 is 9. 9 plus 18 is 17. So I get 17 over 4. So that's my answer for part B. And then for part C, domain again is all real numbers. And then the range is, let's see, well, it's going down from the vertex. So I'm going to say y is less than or equal to 17 over 4. All right, next up we want to do some factoring here. So on number 14, we'll do the x here. So we'll do a times c up top and b on bottom. So a times c would be negative 24 and b would be 23. So I have to multiply to the top and add to the bottom. So that is positive 24 and negative 1. However, I do need to split this up using the grouping since I have this 6n squared there. And so I'll put that there. I'll put negative 4 back there. And then these guys tell me how I split up the middle two terms. So I'm going to go plus 24n minus 1n. They should always add up to this middle term right there, which you can see that it does. And now I'm going to use my grouping technique. So I group these two together and those two together. So on the first group, I can take out 6n, which would leave me n plus 4. The second group, I have to take out something. So even though it looks like I can't take out anything, I can always take out 1 or negative 1. So that's the case here. I'm going to take out a negative 1, which would turn this into a positive n plus 4. I see that I get the same thing in both parentheses, which is good. So I'm going to write this now as 6n minus 1 for the stuff outside and n plus 4 for the stuff inside. All right, last up here, we just have a straight grouping problem. So I'm going to group these two together and those two. The first group, I can take out b squared, which leaves me with 3b minus 5. The second group, I can take out a negative 4, which leaves me with 3b minus 5 as well. So I can make this b squared minus 4 times 3b minus 5. However, I see that I can split this one up further since it's the difference of two perfect squares. I can make it b plus 2, b minus 2 times 3b minus 5.